Welcome to our class session on business processes and system development. Now, this class session could span an entire semester. For example, I have not at this university, but at others, I've taught systems analysis as a whole semester class. Business processes is often its own class, and so we could spend multiple semesters, multiple classes talking about this topic. So we're going to go and hit some of the very big highlights of what it means to be a business process, why does it matter with IT, and then also talk at a very high level about systems development. I'm going to go fairly quickly. As a reminder, though, a couple of administrative items. The database project is due, so make sure that you have completed the database project and get that submitted. Next class, we are going to be in the computer lab, so check the schedule on this. Sections 1 and 2 will be downstairs in the ARC. Section 3 will be in Mendocino Hall, so please make sure to look into that. We'll be working on the analytics project now that we've talked a little bit more about analytics. So first of all, what is a business process? Well, a business process is definitely different than a project. Okay, a business process is, by the formal definition, is a specific ordering of work activities across time and place with a beginning and end and clearly identified inputs and outputs. Okay. It also has been described as a structure for action, which I think is a little vague. I like the definition, the sequential interrelated set of activities. And oftentimes we also are specifically talking about customer-focused activities, although it doesn't have to be. So we're clearly talking about things where there are a set of activities, a set of tasks, a set of processes, a set of things that happen over time. So something happens, then something else happens, then, depending on what happened the last step, either this or this happens, and we can kind of map out how a process works across time and across people and place. Now, in talking about business processes, we're specifically going to be focusing mostly on enterprise business processes. Now, you can have business processes that are, small, like intra-team processes. For example, how do you decide where and when to meet at the next meeting? That could be a small business process that interacts with you and your team. But we're focused on processes, important processes that impact the entire organization. Things like order fulfillment and sales and manufacturing processes that have a tremendous impact on profitability and the competitiveness of a particular organization. So here's an example of an order management process. Now, your organization may be very different, and this may not be as detailed as you'd like, but at a very high level, this might happen in some organizations. A customer, a different actor, a customer, places an order, and then internal to the company, there may be a sales team that reviews the order. There may be, a part of the accounting group that performs some sort of credit check, if that's applicable. And then within the company, there may be an automated system or an individual who checks the product's availability based off of whether it's available or not. We may either make a decision on whether we need to create or to purchase the particular item that we're selling. And if not, maybe if it's already in our inventory, we confirm the order immediately. If not, we confirm it after we've acquired the product that we're selling. And then we process the payment, and then we ship the product once it's ready. And that may go through a number of different groups and individuals within the organization. Okay, we've got the customer outside the organization, but internal to our organization, we may go through sales and accounting. We may go through our inventory management process. And so we have a lot of different systems or humans or both that interact with this order management process. And you notice that it's also a series, a sequential. This happens, then this happens, then this happens. So time is an important consideration here. If, for example, one step in the process is delayed, it delays the overall business process and becomes inefficient. And we need to worry about that kind of thing. Now, why do we care about this? Well, some people have said that business processes really are the building blocks of corporate strategy and sometimes the basic units of competitive advantage. Here's what I mean by that. Can you really enact an overall corporate strategy if you can't get your business processes to support that strategy? Not really. And if you really want to compete with people, we've talked about this earlier before, maybe it's not the software and the hardware that it does the most of the competition. Maybe it's the management information systems that also include the people and the procedures as part of overall processes. Maybe that's where competition really happens. Why does a particular company perform so much better than another company? For example, why is Walmart so much better than Kmart/Sears nowadays? Well, many people could argue, that Walmart's bigger, so they can manage, they can negotiate, better prices on goods. But a lot of people have pointed out the fact that they just have better business processes than that organization. They're just more mature and more efficient. But it's the business processes that matter, not the particular hardware and software and other things. It's the processes. Now, processes also help us to focus on things like customer orientation, which I already mentioned, but also on organizational efficiency and reliability. And if you're a good organization, can you have processes that also include other organizations that still remain efficient? So interorganizational integration. We gave the example earlier when we were talking about enterprise systems and extranets of organizations like Walmart with their vendor managed inventory, or with Dell with their just-in-time inventory. But can you really work with a business process that has multiple stakeholders that might not have the same motivations? Well, if you're a good, efficient company, you can. All right. And then others have mentioned that business process performance actually may better measure and predict corporate financial performance than a lot of our other measures. Sometimes we look at things like, our sales. Is that going to be a good predictor of our overall company net income? Well, maybe if we can leverage those sales and drive down our costs, but whether our business processes are efficient or not might actually better predict some of our performance measures that we care the most about. So business processes, we've talked about this a little bit. Some of our business processes are very structured. And what I mean by that is that we can easily draw them out on a piece of paper. This happens, then this person takes it and does this person does this. Oh, well, what happens if this happens? Oh, well, we either do this or that depending on the outcome. And so those are very structured business processes. They're those that we can define easily and that we can go and map out, help to optimize and figure out. Some of our business processes, though, are just much more dynamic, meaning they change much more over time. Things like, how do we collaborate within teams? How do we collaborate across organizations? Those tend to be processes that are a little bit more dynamic. And they're still business processes, but they just change a little bit more over time. Now, another way we can look at business processes is based off of the scope of the business process. And we've already kind of talked about this. We may have business processes that are more enterprise, organizational business processes, the item in the middle of this list. We may have those that are inter-organizational or inter-enterprisal, those that cross different organizations. And we may have those that are a little more local to us, down to the team or even the individual level. We may have our own internal processes for doing certain things. But within teams, within divisions, local processes can also make a difference in the organization. All right, so how does IT change business processes? Well, realistically, it happens in a couple of different ways. Number one is sometimes technology can impact the structure of the business process. What I mean by this is if you're mapping it out on the board, like in this picture, if you're mapping out what happens when, IT can change how that works. Maybe it replaces some parts of the process with technology, with software. Maybe because of the way that things are handled, maybe the order changes or the decisions change. Maybe the arrows change around based off of applying technology or various different technologies to the process. The second way that IT can change business processes is in terms of resources. So maybe there's a particular process that does need human intervention, but maybe it can be dramatically sped up by the application of technology. Whereas, if this is a decision support system, for example, maybe the decision that the human needs to make can be dramatically sped up. And so the resources, the technology, can impact the business process by making it more efficient because the resources are there. We'll talk a little bit more about this later. All right. Now, in the textbook that most of you are not using, I want to be clear in case for those of one or two of you that do like textbooks and did choose to get the optional textbook. Business process management is proposed in the textbook as an alternative to the software development lifecycle, or SDLC, or to Scrum. And that just is not at all accurate in any stretch of the imagination. So just be careful on that. The textbook is definitely incorrect on that. The important part of this, though, the slide, is that there are a number of different names for doing something called business process reengineering. That's the most common name. Here's a laundry list of other names that this might be called: business process improvement, process redesign, process optimization or integration, process standardization. A lot of different names for taking our business processes and changing them, modifying them in some way so that we improve, make them more efficient, make them more streamlined, take out parts that are unnecessary, make them more profitable, make them more creative or collaborative, whatever our metrics are that we're trying to focus on. Business process reengineering is to take our processes and make them better. And over time, as business process reengineering, or BPR, has kind of become not as cool of a name as it once was, sometimes consultants will come up with new names. Oftentimes we mean the exact same thing. We're trying to improve our business processes. Now, we've talked about this before when we were talking about enterprise systems. If we have existing business processes and we need to upgrade our technology, or want to upgrade our technology, and the technology doesn't support our exact current business process, which do we change? Now, this is an important distinction, all right, which is why I talk about it in multiple different class sessions. Do we change the process to match the technology? Do we change the technology to match the process? Those are hard decisions to make in an organization. We have to evaluate whether our business process that doesn't mesh with the technology, if the aspects that don't work with it, if those are something that provide us with competitive advantage, or if we have to do it that way. Or does the technology, not support our really efficient, really exceptional, and competitive advantage providing business processes? If so, we need to definitely change our technology to meet our outstanding business processes. But these are hard decisions to make. All right, so that's business processes. I want to lead now into systems development. Systems development is very important, but as a starter, I usually in class have a discussion of healthcare.gov. Not because I want to be political, and healthcare.gov and the Affordable Care Act, is a very political issue, but because healthcare.gov is a great example of what happens during a systems development process. And this one happens to be probably the most widely publicized systems development process. This one happened to have some problems, but in the last few years. And so I pick on this not for the political issues. I don't care whether you think I'm Republican or Democrat or something else. But let's talk about this as a systems development example. So if you're not familiar with healthcare.gov, maybe go to the website and check it out, provided it still exists under the current administration by the time this class runs. But the healthcare.gov website was created as part of the Affordable Care Act, or the ACA, which is popularly known as Obamacare. So this was signed back in 2010, and part of the Affordable Care Act was that this site would be created so that people could purchase healthcare who didn't have healthcare plans, so they could get insurance. The problem is, when it went live, it didn't work. It was unable to handle the load. It was dramatically, embarrassing to the administration because they just couldn't get it to work. The problem was that there are a number of different issues here. Number one was The company that was contracted to do this, CGI Federal, is the 29th largest federal IT contractor. And this was a very important sort of showcase project for the Obama administration. And many are now saying, the process of deciding who to contract was actually fundamentally flawed. To be a federal contractor, many of you are aware of this, to be a federal or state contractor, there's just a lot of hoops to jump through, a lot of paperwork to fill out. And CGI Federal was one of the largest and most capable of the IT contractors who decided to jump through all the hoops on this one. Some IT companies just wanted to stay away because it was a political issue. And so perhaps the best contractor wasn't selected because of the contracting process. But then beyond that, CGI Federal decided to hire 55 different contractors in order to do different aspects of the work. Because this system, it wasn't just a website, but this system actually needed to have data from the insurance companies. It had to have data from the information services from various agencies, including credit reporting agencies. It had to have information from customers that was input, and it had to work with all of these within this, the laws that are part of this and other acts. I want you to think the last time you tried to get a few people to agree on where to go to dinner, if you're going out to a restaurant. What happens when you add more and more and more people who need to agree on which restaurant you're going to, and when you're going, and what everyone's ordering? This becomes challenging as we add more and more people to the equation. And so let me just say 55 contractors is a lot for a project. And getting them all on the same, on the same page, and getting them all to do the work and to program and to get everything integrated properly together is very challenging. Not surprisingly, there are reports that there was no end-to-end testing of healthcare.gov before it went live, and that the testing of any sort may have started 2 weeks before the initial go-live date. So, of course, what happens? It fails spectacularly. It can't handle the load. It crashed a number of different times, and many people needed to be brought in to fix the issue. And eventually it was somewhat fixed to the point that some of the parts that were supposed to be automated were outsourced to humans manually doing things, and some of it was legitimately fixed. Another challenge with this systems development project is that some people said that it was so many lines of code. It was so big of a project. It was reported in the media that it was 500 million lines of code, although that's since been debunked. It was estimated that there were 3.7 to 15 million lines of code in this system. Now, lines of code is not a very good metric for a largeness or complexity of a system, because you can use software libraries from other people and artificially inflate your lines of code. But just as a comparison, Windows 7 and 8, I haven't seen an estimate on 10, are estimated to be in the 30 to 50 million lines of code range. And Mac OS X, that operating system, is estimated to be around 86 million lines of code. Which means that this system was, perhaps as much as half as complex in terms of lines of code as Windows. And that is very, very complex for a very short-term project for a federal contractor that perhaps isn't that sophisticated. And so anyway, this is an example of a systems development project that was what we would call challenged. Let's move on to this. There's an organization called the Standish Group, and every year they do a report that they call the Chaos Report. They started many, many years ago. The data that I have in this chart begins in 1994, and they evaluate whether IT projects succeed completely. Okay, for those of you who can see the success, that's kind of the gray line here. Whether the projects were challenged, meaning they had problems, either they were over budget, they were over scope, or parts of the project had to be cut. Those are the orange lines, if you can see it, this orange line right here. or whether they failed completely. The project had to be scrapped for whatever reason. That's the blue line here. Now you'll notice that 2011, 2012, there's kind of this gap. The reason for that is the Standish Group changed their metrics for how they defined succeeded and challenged, but they kept the old metrics for a year. And so these should be smooth lines, but they're not because of these change in metrics. But what you should notice here is that the number of projects that succeed, okay, tops out, completely succeeded, no problems, tops out at around 39%. And recently has been just under 30%. You know, would you buy a car that only had a 39% or even worse, 30% chance of driving off the lot with zero problems? Probably not. So this indicates, you know, there's some challenges. IT project management is challenging. Getting projects to succeed is challenging. Now, are we getting better over time? Is the success rate increasing over time? Yeah, it appears to be. The failure rate seems to be decreasing, but we're still having a lot of projects that are over time, over budget, more than half according to the new metrics. Some have estimated this problem to be so bad that it actually causes $3 trillion worth of cost to the worldwide economy. That's how problematic all of these IT failures are. So, why does this even happen? Here are some of the most important reasons why IT projects fail. I want to highlight a couple of them in detail, but let's go through all of them. So why do so many IT projects fail? Well, the number one reason for years has always been missing unclear or changing requirements. Now, this also has to do with the fifth one on the list, scope creep, but I want to talk about that one separately in just a minute. So the idea here is that projects, we do them because they're going to give us something. You know, they're going to give us some, you know, if it's a software that we're trying to implement, it's going to give us some additional functionality or features. It's going to make things more efficient. You know, if it's a piece of hardware that we're implementing, you know, maybe it's a Wi-Fi access point, maybe it will give us wireless access in a particular part of the building or better access than we've ever had before. And so we need to develop, before we do the project, we need to develop what the requirements are. What does the project need to accomplish? What does it need? What do we need to do in order to make those goals happen? And strangely enough, oftentimes that's missing from IT project management, from the systems development perspective. We don't do that as well as we should. We start projects because we think that they're cool, or that somebody decides that, hey, I need a project. We need to get with the times. Let's make an app, but nobody defines what should be in the app. All right, and so this is one of the reasons why projects fail, is because the requirements just aren't there. The second thing is lack of planning. Now, this seems completely obvious that you should plan for your project, but it is amazing to me how many teams just start working on things without actually planning. It kind of goes with the idea of, missing requirements, is that we're just skipping out part of the process. We're just not doing what we should do beforehand. The third item is limited executive support. Now, every organization is slightly different, but you should never undertake a large enterprise level project, something that costs a lot of money and can influence a number of different aspects of the organization, without some fairly high or very high executive support. Now, small projects might be a little bit different. You might need a manager or a divisional support or something like that. But a lot of IT projects fail because they don't have the executive support. So when an executive might change, or when an executive might notice the project and go, why are we committing resources to this? Who ordered this? When the executive support isn't there, oftentimes projects get canceled or changed, or there's problems. Limited or problematic communication is next. And this is obvious. When we have poor communication, things go badly. Number 5 is a really interesting one. It's this concept of scope creep. So the scope of the project has to do with the requirements. It has to do with the idea that you set out to make a particular project, and it has a certain scope. And so when you start a project, you figure out the scope, and then you budget for it and plan for it, and you evaluate the time frame for completing that particular project. What scope creep is when that changes over time, and in particular, it grows over time. So maybe we start a project where originally we were designing this project so that it would benefit this one particular division in the organization. Maybe it was going to help out the accountants. And then all of a sudden, one of the other managers goes, "Oh, I like how that's going to help out the accountants, but I'm in marketing and I'm not going to get benefit for that system. Why don't we just add a few things to that system and then we can use it in marketing?" And then someone else plays golf with that marketing manager, and all of a sudden, another group within the organization says, "Oh, well, we could use that too, but if it would need, these 10 additional features." And over time, this project just gets bigger and bigger and bigger and more complex, and more features are needed. And that's when projects tend to really fail, is when the scope gets really, really big really quickly, and we just can't support it with the budget and with the time frame that we originally were planning on. The next one is changing technology. Now, this does happen. Technology changes all the time, and sometimes it changes to the point that it obsoletes our current projects. And why would we want to continue with our Laserdisc project when we can put it on DVD, or when we can just stream it online? Okay, and so sometimes the technology changes will make projects so that they need to be canceled or fail. Another big one, sometimes I think this one should be higher up on the list, but it's an important one, is lack of testing and quality control. This is usually, not always, but usually towards the end of the process, okay, after we've done some development and creation of a particular piece of hardware or software or whatever it is, and then we test towards the end to see if everything's working. But what happens when the project is running over time? What gets cut first of all? Almost always the first thing cut when we're running over time or over budget is testing or quality control. We just don't do our quality assurance evaluations, and this can lead to even worse problems in the long run. And then the last one is forecasting is hard. It's really hard. And so doing estimation, doing return on investment calculations is just challenging to get exactly right. As a general rule, when we want to estimate a project, we need to try as much as possible to compare it to something that we know already. Look at things like old projects and see how long it took to do some similar tasks for those projects, and also to get the right person doing the estimating. Some people are just better at estimating than others. As humans, we have biases towards being optimistic in many cases, but we need to be realistic when we're estimating projects. So this leads us to something called the Systems Development Lifecycle, or sometimes the Software Development Lifecycle, or the SDLC. So this life cycle helps us to define what are the different phases or stages that happen during the development of a system. So these systems development lifecycle stages, there is a fair consensus about all of the different things that go in them, but there is some disagreement as to how these get chopped up into different stages. Now in this class, we're going to use a 4-stage model where there's the planning stage, analysis, design, and implementation. But some individuals break it up slightly differently, but in this class, that's how we're going to break it up. Let's walk through what happens in each of the different phases. So first of all, what kind of questions are we asking? In the planning phase, we're asking the question, why would we ever want to put money towards this project? Why are we doing this? Okay, that happens during the planning phase. We'll get into more detail in a minute. The analysis phase. Who is going to use this system? What are they going to do with it? When will this system be used? And where within the organization, or sometimes within the country or city, is it going to be used? Then during the design phase, we ask the question, how are we going to create the system now that we know what it needs to do? And last of all, we actually build the thing. We install it, we test it, we support it, and we maintain it. okay? All of the actual hands-on part. So more on the planning phase. So the planning phase is all about identifying business value. Is figure out what our estimates are for, our financial estimates. Is this project going to provide value for the organization or not? We also evaluate other types of feasibility besides financial. We do technical feasibility analysis, where we look at things like, do we have the current expertise in our organization? And is it even possible? There's a famous case with McDonald's a few years ago of trying to do a project that the technology just wasn't there yet in order to make this happen. And so sometimes we have to wait for technology to either become cost efficient enough for us or to even exist to do certain types of projects. Is this economically feasible? We already talked a little bit about financial measures, but we can look at different types of return on investment analysis, and we can even be much more fancy. I talk about this in other classes. We can even use things like options pricing model, Black-Scholes kind of stuff in order to evaluate projects, and that's an interesting way of doing it. Organizational behavioral feasibility have to do with the idea of, does our particular organization have the expertise to do this? But also, does it work with our business processes? Does it fit into our existing environment? And will we have problems with resistance? Are there cultural things around our organization and around the people who work in our organization that make this problematic? We evaluate those things and we're trying to plan the project. One of the outcomes, though, of our planning phase is we make a sort of a go or a no-go decision. Are we going to go ahead with this project or not? That's one of the deliverables of this phase. And again, why should we build this? The second part of this is we figure out all of the planning stuff that needs to go along, what the project manager needs to do. We develop all of the different tasks that need to be performed. We come up with estimates of the time that is required. We, do our work breakdown structures. We do our, all of the different things that you talk about in other classes. Sometimes this is discussed in OPM and other project management classes. And we work on all of those and then figure out, how is this project going to be staffed, who's going to be in charge of it, and we build this plan. And so we develop, we have a decision on whether to go ahead with this project, but we also have a project plan moving forward. Now, the analysis phase is really important, and it's often overlooked or minimized when it shouldn't be. In an IT project, this is very important to have. First of all, we have a strategy for doing analysis. But most importantly, however we decide our strategy, we need to gather those requirements. So the analysis phase is largely about getting the requirements and documenting those requirements. What does the system need to do? And so we answer these sort of questions that we've already talked about. Now, we do that through various different types of modeling oftentimes. Now, we also capture, narratives on what the system needs to do. But we have a very, standardized set of diagrams. We've already talked about ER diagrams in this course, so things like that. But we have other diagrams out there to help us identify what are the business processes. How does the software need to do various things? And more complex things that are beyond the scope of this class. And we develop this list of system requirements, and that's kind of the deliverable for this phase. Then we have our design phase. Now, our design phase is different than the analysis phase, but it's easy to get them confused. Here's how they differ. In the analysis phase, which we just talked about, we get the requirements. In the design phase, we figure out, how are we actually going to build this system? We know what it needs to do. How do we do that? How do we design our user interfaces? How do we do something that, again, is beyond the scope of this class? Designing our architecture. Things like, is this a client-server architecture or is it not? How do we design how our data is going to look like? And so we often use ER diagrams in this phase and other diagrams. How do we figure out where our data comes from, the inputs and the outputs of the system? What reports or deliverables or dashboards or what does the system need to output? And then we design at a fairly high level, but somewhat detailed level also, the program itself, the software aspects, and we have some mechanisms that in order to do that. Our last phase is the implementation phase. Now, implementation can mean a lot of different things. It can be go out and buy a system that's already been developed, or contract with a company that's already developed a system and have them come and install it. Or it can mean go and get busy programming and developing in some software through creating some source code. It can mean a lot of different things. But the systems implementation process definitely also should mean that we are doing testing and that we support and maintain this system once it's in place. Now, when it's time to install, or deploy in this slide, when it's time to install, we have some options. We can do a big bang approach, a phased approach, or a parallel approach. And each of these has pros and cons. Let's talk about them. A big bang approach is where we basically turn off the old system and turn on the new system and hope everything works out properly. Now, you might not be surprised that this is the riskiest of the deployment options, but it's also a fairly easy option. Okay, it doesn't have some of the downsides, but it is very risky. If everything works, then great, everything works. Let's go to the parallel first. So the parallel deployment process, what that one means is we leave the existing system up when we turn the system on, and we run both of them at the same time. Now, here's the problem with that, is sometimes this leads to even worse resistance as people continue to use the old system and revolt and not decide to use a new system. But we also have duplication of work. What if we need to put data into the old system and the new system in order to make them work? What if they don't have the same data store for whatever reason? That can cause a lot of inefficiency and some problems. But it's less risky. If one system isn't working, if the new system isn't working, then, well, the old system can still be used. What's most common probably is the phased approach. And here's how that one works. We will take a subset of the company or the organization. Maybe it's one location, maybe it's one department, one division, however we divide it up, and we will have that group deploy the system. Whether it's big bang or parallel, it doesn't really matter. And then once the kinks are worked out, once the problems are found and fixed, then we will expand that deployment to other groups until eventually the entire organization is using the system. All right, so those are the 4 phases. So ultimately in this phase, we are building the system and we're ending up with hopefully a fully functional system that's ready to be supported and maintained as it goes into operations. Next, we're going to talk about systems development methodologies. So we have our 4 phases, but you can organize how you make those phases work sequentially very different depending on your organization. We'll get to what I mean by that in just a second. But this is a little slide. It's a couple years old now, but it's a slide from Scott Ambler. Scott Ambler's a fairly famous guy in the object-oriented systems development world, as well as the agile world, and which we'll talk about in a minute. But what he adds in this slide, which I think is really interesting, is we looked already at the successful, challenged, and failed projects. What he's done is done some surveys that identify that the methodology you use actually has implications for whether you are going to have more or less failures in your company. And so he argues for agile, iterative, or lean systems development methodologies instead of either ad hoc or traditional, which are closer to what we'll talk about in terms of waterfall. And so, just the point of this is that the different methodology you use may have a higher chance of project success. So let's walk through some of the big picture. There are a whole bunch of different methodologies and a lot of different variants of all of these. I want to talk about kind of just very big picture, very broad ideas. So The sort of the old methodology, the traditional methodology, is what we call the waterfall methodology. This methodology tends to work fairly well in non-IT projects. It has some challenges for IT projects. Here's how it works. You start with the planning phase, you do all of the planning phase, and then you move on to the analysis phase. Then you do all of the analysis phase, and then move on to the design phase, and so forth. And so you do everything without really going back at all. Now, this works well if your project doesn't have to be changed halfway through or has requirements that need to be changed part of the way through. But if that's the case, if there's change that needs to be thrown into, this process really doesn't work very well because you'd have to go all the way back to the beginning and replan and analyze and redesign, and it just is not very forgiving for changes in requirements. So the next one I want to talk about is the prototyping methodology. This one happens to be closer to Ambler's iterative. We'll call this prototyping. Here's how this works. We start off with the planning phase, and we do a full planning phase. Then we work into doing some doing some analysis, doing some design, and doing some implementation. We do all three of these phases in sequence until we create a prototype. Now, a prototype can mean a number of different things for different organizations. Some of them may be very feature-rich, and some of them may not be at all. But we create a prototype and do a little bit of evaluation of that. And then we go back and redo some analysis, design, and implementation until we come up with a prototype that we're happy with. And at that point in time, we stop our iteration and we move fully into a subsystems implementation. The advantage of this is we tend to work out a lot of the problems as we're prototyping along. The disadvantage is that this may take quite a bit of time before we're ready to have a prototype that we're happy with and before we do any implementation. So, time is money. The longer we spend doing this iterations and figuring out our prototypes, the longer it takes before we get any benefits of our implementation. The last one is Agile. Now, Agile is usually represented as a cycle, even though it's a little messier than this in real life. The idea with Agile is that we make each of these little cycles a fairly short period of time, in the 2 to 8 week range. And in those cycles, we do a little bit of planning, then some analysis, then some design, then some implementation and testing, and then go back to this process. And the whole thing is cyclical. So in one of the variants, for example, of Agile, which is called Scrum, which is based off of the rugby term Scrum, these cycles are called sprints, and we do them every 2 to 8 weeks, and we have weekly meetings to talk about these things, and we just iterate. Now, the advantage of this is that there's something in systems development and other things that is called the 80-20 rule. And the 80-20 rule can be adapted to a number of different phrasings, but here's the way I like to use it in systems development. We can usually implement 80% of a project in 20% of the time, and it's the last 20% of the project that takes 80% of the time. And so one thing that's cool with Agile is if we go through these sprints, and every single cycle we can create or analyze, test, implement some functionality, and then the company or the group or whoever's using the project can start to gain benefit of this. And then over time, this grows and grows as features are added and added and added. So here's an example. Google does a lot of Agile methodology. With the Chrome browser, which many of you use, Google has moved to a very quick release cycle. They use an Agile approach where every single release, they don't make a humongous change, but they make small changes every few weeks. They go through this Agile process, and so Google Chrome, last I checked, I think it's up to version 52 or 58 or something like that, because periodically they just have new updates all the time as they go through quickly and plan and analyze and design and implement, including testing, and then they release and then go back and keep on iterating over this. Now, the disadvantages of Agile are, well, sometimes we can be stuck in this loop and not ever finish the project. Okay, that's problematic. It costs a lot of money to keep resources on a project. It also may not be as good for large projects, huge organizational projects. There's some indication that Agile is a little weak on that. And there's some indication that with Agile, the trust of the team is more important than in other methodologies. Sometimes we'll have teams that might not like each other, or that might be teams that depend on each other for certain aspects of a project. With Agile, there's some indication that close-knit teams that work well together, do extremely well, whereas they do very, very poorly if they don't get along well. Okay. So in class next time, we're going to work on a methodology exercise to hopefully kind of make this a little more concrete for you. What I want you to do next, though, is go on StackCT, or not on StackCT, on Top Hat, and answer your questions. So we have some Top Hat exercises on StackCT. So do those. Don't forget those. But next class, we will be in the computer lab. We're going to be working on the analytics project. I want to remind you of that. And next lecture, be aware that our class is going to be online also, just like this one. And we're going to be talking about user interface design and evaluation. Make sure to do the readings before our class period is set to start. All right. Thank you much.